Hello. So this year in May, I was in San Francisco in a very big conference. It was the largest conference I ever been in my life. It was like more than 2,000 people. And there I meet a lot of inspiring lecturers, coaches, trainers. And one of the days we have a cocktail at the night, and I approach one of them, and he was very nice to talk with me for a couple of minutes, and he gave me advice. He gave me advice that I think about a lot of time and think how one speaker needs to open his speech. Do you know what he told me? Don't bore your audience. So I'm not going to bore you. I'm going to try not to. And that's why we're going to cut to the chase. And I'm going to tell you that we're going to talk about cost saving in this presentation. Everything here is going to be about cost saving and how you need to do it from end to end. And before we begin, I want to ask you a question. Do you know how much a heart is beating in gigahertz or hertz? So approximately a heart cycle is around 1 hertz, from 1 to 1.6 hertz. This is for a second. And if we make a small calculation for around 80 years, let's say your lifetime, you're going to understand and see that a lifetime of a heart, it's around 2.5, 3.5 billion cycles. And now the bigger question is, how much time spends a modern CPU to do that? Anyone? Not seconds. 1 second is capable, a modern CPU, 4 gigahertz CPU, is making 4 billion cycles per second, which means 1 second of a modern computer is your lifetime plus some extra cycles. In that matter, we're going to talk about computers and why we should leave the cloud to the machines and watch engineers reach new heights. Why I need to do that and spend a lot of my personal time when the computer is doing it much more faster. So to understand why the automation, it's not something that it helps us. So it helps us at some point. And at some point, it's a must. You cannot do it without automation. So yesterday and today, I heard a lot of lectures about pipelines, automation, testing, etc. And everything I heard there is about developers, how developers test their codes, and everything's about the code and the developers. Now, here, this lecture is completely different. It kind of sounds like the same, but it's different, and it's about the servers. So we're talking about the engineer part here, the servers, not the code. The code is involved, but not so much, okay? So if you know services if you want to make a business, you have 2 things to think about. One is the infrastructure, and the other one is the service. So what is the case here? You have a stable infrastructure. Everything's fine. Servers are working, hard disk are failing, everything is redundant. But you go to the service, you want to buy something, and the billing system is not working. That's not good for you, right? As an end customer. You don't care if the server is down or the code is not working. You care about your thing you want to do, to buy something or order, whatever. So you need to have a balance. You need to have stable infrastructure and stable service, which is the product you're doing. So in that matter, I'm going to show you some statistics of our environment in VMware. I'm from CPE team, which is supporting, developing, and providing services in VMware Internal Cloud. And as you can see, we are spread across more than 100 offices. We have more than 8 data centers, more than 8,000 ESX hosts. This is the operational system of VMware. And if you think that 8,000 servers, hardware servers, not virtual, are not so impressive thing, look the numbers a little bit more. Because we are creating and destroying over 1 million containers. We have containers, we have virtual machines, and this is a lot. So at some point, automation is good. If you want to install a single server, you can do it manually. If you want to install 3 or 5 servers, you can do it manually. It's going to take you much more time. 100 is going to, you can do it at some point. 1,000 and 10,000 and millions, it's impossible without automation. So now I'm here, I'm going to explain you about the scale of one company. And if you're still not impressed from the numbers, I'm going to tell you that in our environment, we talk about petabytes. Terabytes are less, okay? And if you're still not impressed, I'm going to tell you a real story that when I talk about memory and CPU to our customers, I'm talking about memory in terabytes. And they're like, 4 terabytes, you mean gigabytes? No, I mean terabytes. Memory, okay? So as you can see here from the diagram, we start around 2012. I joined the team 2013, and we had around 20,000 VMs. That's virtual machines. And as you can see, you're scaling very fast. And right now, 2019, we have 500,000 virtual machines. Okay? And how you can support that, how you can do it. And the most important thing is how you make more virtual machines and the cost is going down. And that's why we're here, to give you some advices and things how we do it, to implement that in your company. So a lot of questions are shooting me like, what is auto-remediation? And this is auto-remediation. When you see auto-remediation, you actually employ a computer to do the job and to respond to your alarms, events, and fix things for you. That's auto-remediation, an employed computer. And auto means don't act as a script. Okay? Let the computer do the job. So if something the computer can do, offload it to the computer. And the remediation means clinical alert. So actually fixing the issue. Okay? So if we talk about auto-remediation, we can, on a high-level plan, we can split the auto-remediation into parts. One of the parts is the investigation and validation part. And that part is actually when you get an alert, you need to understand if the alert is real or not. Because sometimes you get an alert, but it's a fake one. So you need to split that on 2 parts. The real alarm, which we're going to trigger the automation, and the automation will do its job. Or the fake alarm is going to escalate to engineers. That means when the fake alarms is arrived, we know about that, and we do something about it. Which means we will never receive a fake alarm again. That's the holy grail, right? Real world. And the second part is, if the alarm is real, you trigger the automation, and the automation is trying to fix the issue. But sometimes, in very different cases, you have new version of the software, or you have new firmware of the BIOS or the controller, whatever. The automation cannot fix the issue. Then it escalates to engineer again. And what we are doing here is we see what is the gap, and we fix it. So we learn from our mistakes and get better. Okay? So in the perfect world, at some point, we don't receive fake alarms, and we don't have issues which are not fixed. But the version of the script and the automation is getting better and better and smarter, right? Right. So to understand what is the two different ways of fixing an issue, I'm going to tell you a story, how engineers are involved in that. What is going on when you receive an alarm. So I'm going to show you a typical process, what is going on when we receive an alert or a problem. OK, so 1 a.m., you receive an alert from a server, from a router, switch, whatever. There's an issue. Alarm is in our queue. And then that's the NOC team, that's Network Operational Control Center. And those guys, their job is to watch the alerts and decide what is real or not, and they decide if they can fix it or not. Okay? So let's say the guy sees the alarm, and he said, I cannot fix that. I need to escalate to a higher level. So what he's doing, he's picking up the phone around 1:10 and calls you. Actually, if you're a developer, in most cases, nobody's going to call you. They call me, because I'm the engineer and I'm responsible for the servers. So I receive a call around 1 a.m. and 20 minutes. The phone starts ringing. My dog is barking. The girls get up to see what is going on because the dog is barking. And when you pick up the phone, you're fully awake because of the chaos in your house. Okay? You get the phone, and after that, you start searching your laptop. Where you put your laptop? Is it on a bag or somewhere else? Do you have a battery or not? And then you log into the VPN. That's your access to your company. Okay? You log into the VPN, and then it's the part of verification and validation. You check what is going on. You go, you search about the problem, and what engineers are doing, and developers too, we troubleshoot the problem step by step, and every step goes to another step. So we make a decision based on the output of the systems. We check what is going on, and let's say we find the root cause. The root cause is the actual problem. And then we see that there is a run book. If you don't know what is the run book is very well-defined documentation about specific problem. So I have low disk space, and I have run book what to do on low disk space. Clean those files, delete those files, remove those files, archive them, backup them. You know what to do step by step. And you implement that, because it's straightforward. And bam, 2:30 a.m., problem is fixed. And it took you around, how much? Hour and a half, 2 hours, 3 hours? It depends on the problem. That's the real thing, how things are running. So how actually the auto-remediation is doing that? Let's see the same case, but now we self-employ a computer to do the job. So you receive an alert from your object. Then this is passed to the automation. As I said, the automation is making the validation and the verification for you. You check, see the alarm is real or not. Let's assume that the alarm is real, and then just implement the fix. Because actually, here on the runbook, you know what is the case, and you know how to fix it. So you just make the automation to do it for you. Okay? What to automate and what must your goals be? That's our team goals. Like more than 95% must be automated. 3% of false alarms and 2% escalation to engineers or humans. And if you remember our 500,000 VMs, you can calculate 2% of half of VMs. So it's pretty much huge amount of work. So we are trying to do our best and going bigger and bigger to automate and offload more and more to the computers. So, what is the traditional way of doing things and how? And there's still out there firms doing that. And that's the way how I worked before, like 15 years. So you have a custom scripts, which are running on cron jobs, running on some systems which is totally untransparent. And what is the case here? And you do it manually. You have the problem, you fix it. So imagine what is going on if you receive a warrant for low disk space at 1 a.m., Monday, Tuesday, Wednesday, Thursday, Friday. After 3 weeks, ask your wife how it feels. Okay? So you need to do something about it. But you're doing it manually. You're here. So it's hard. The other problem is there's no transparency. That means you don't know when it runs, how it runs, what is the output of the automation you wrote, because the script, it's not like you have a standard output. But when I was doing that, there was no thinking about combining all those custom scripts and creating like a report for you, right? Other aspect is the graphical user interface. I'm not saying that you cannot automate a graphical user interface, but how much the graphical user interface is automated or not. And if you need to do something on the graphical user interface manually, because you need to click a couple of boxes and buttons, let's talk about 8 data centers and 100 people of support. So they need to do that in different locations in APAC, in EMEA, in NASA, and everyone needs to do it. So because you're doing graphical user interface, you're doing a manual job. So it's like something related. And then one of the traditional ways is that people which operate those systems, they don't code and they don't keep it under source control. That means the guys who operate those systems are the system administrators. Okay, that's me. My background is a system and network administrator. And back in the days, I was not able to code. I'm talking about pure code. I'm not talking about writing a bash script here and there. I'm talking about open a real program language, like Python, Ruby, Go, whatever is suits for you, C. And you don't use source control. That means system administrators don't keep their servers under source control. And we're going to talk about a little bit more new slides about that, how you're going to do it. And a real story was that I was hired for a firm to tell them what their issues are, to give them advice how to improve their work. And I noticed that 5 developers was opening WinSCP, and they opened like the index.php file. And they are trying to make changes on that file. So the first guy opened it, saves it, then the second one. And I told them, you need to use source control. You cannot just open a file, save it, close it. What you're going to do if there's a problem? Oh, we have a backup. That's not the right way to do it. You need to do it with source control. You have versioning. You know what is going on. You see who did what. And the developers told me, we're just 5 guys in the office. You're just trying to overhead our process, and that's going to like backfire us. I said, OK, it's up to you. I just provide my recommendation. After 3 weeks, a big company entered their office, and because they have respect to it, they told them, you don't use source control? What's going on? How you deal with all the problems? One day, they implement source control. Okay? So what is the current situation, how we are doing it right now? So we're talking about infrastructure as code. And someone will say, what? Infrastructure as code? I heard a lot of as code things, you know? Everything is as code right now. Code as a code. And infrastructure as a code means that you put your variables and we call it desired state, how your infrastructure must look. You put it in a code, and you just pass the awesome developer's way to handle code. So you test it, the dev or the test environment, you test that, you see it's working. And what you're going to do is you're going to pass a code review. I'm not sure if some of you are make code review process in your companies, but actually what it's doing here, I push my branch, and then the CI/CD pipeline start checking some things, right? Is there passwords in the code? If you ident it right, if you follow the best practices of the language, everything. And then the good part is the humans. You have a human review your code, which means every team member in your company is seeing your code and give you advice of it. No, that's not good to do it that way. Let's do it this way. You start conversation, and because you get a knowledge from a lot of people, let's say 10 of them, you're getting better and better. The next day, you're doing code review. But before a week, you didn't heard about Python. So things looks very good for you. And then you move to stage environment. If you don't know what stage environment is, the stage environment is the exact environment like the production. But it's not a production. And if something is wrong and breaks down the system, it's going to break down this system. That's not going to affect the customers. So you go to staging and you see everything is cool. And you push it to production. And then you pass again a review. Sometimes it depends on what system you're trying to push or not, but it's different. And the stage to production push is more like, is this impactful? Can we do it in the weekdays? Can we do it in the weekends? Do we need to inform our customers or not? Such things. More like not technical, but more like from the service point of view. And that's it. You're in production. Everything's fine. Everything's cool. So you move to transparency automation workflows. And what is that? That is your custom scripts in a single, like a bucket. You see script 1, 2, 3. You see what did script 1. He passed parameters to script 2. Script 2 passed them to script 3. Every script is successful or not successful. And you start making your logic, what is going on, if the script is failing or it's successful. It's up to you. But at the end, you have everything in front of you. When, how, what is the output? Everything is there. And then the operational team, like me, they see all the benefits of that. They see all those things, and they start coding by themselves. No? You convince them that the code is good for them. It's not something you force them to do. And speaking of benefits, let me give you some ideas of benefits in auto-remediation. And one of the factors is avoid human factor. And what is the human factor is that people make mistakes. And will continue to do it. And if you think that they're going to stop making mistakes, you're so wrong. So you don't try to force people to be more careful and more careful and stress them. Be very careful with that system because it's very, can cause a huge impact. You avoid that. You just try to work around it. So you don't involve people in fixing issues. Then you go to prevent incidents proactively. What means proactively? Means you're ahead of your time. You see in future. You see a whole disk space on a Linux box. And you see in the future that after a week, that space is going to be 100%. And after that, it's going to be service impact. That's going to be Matt's tenants calling you, what is going on, why my server is down, and that's it. And what you're doing is you see the problem and fix it before it can hit you. That's a proactively. Think in front of you. Other thing is saves you time from troubleshooting steps. So as I explained you the process, around 2:30, 1 a.m. and 30 minutes, you're checking the problem. You're trying to find the root cause of the problem. But what you're doing, you're checking the disk space, you're checking the processes, you're checking the memory, the CPU, the disk, whatever. What if someone already did that for you? And the automation is trying to fix the problem, doing all those steps for you, and then said, I was able to fix the issue, but I have a report for you. Here is a report for the EO usage. Here's the report for the CPU, for the memory, for everything. So you don't need to do it. Someone did something for you the last 5 minutes. Other thing is run book as a code. So you don't have documentation, you have a code. And back in the days, we had a trainer called Randy, and he told me there are like 3 types of people, like people who read C code, write C code, and read and write C code. And he was like, what? Documentation? That's outdated. User search Linux drivers, E1000. And he started read the code. And we was like, what? This guy doesn't read the documentation because it could be outdated. And now your documentation is a code. And your operational team can write and read code. So why bother updating the documentation? And yes, we have doc strings. We have documentation inside directly in the code. So it's perfect. Everything is fine. Great way to avoid burnout engineers. So that's where you stop burning out your engineers, and they have more time to do more important stuff like optimizing the automation, right? And they're like more happy than ever. And other aspect is allow you to easily meet your SLA and SLO. That means I'm gonna talk about that a little bit later, what is the case there. So what are the challenges? Team adoption. You need to convince your team, the entire team, not 1 or 2 guys, that this is beneficial for them. And then when your entire team can write automation, you're gonna like skyrocket. Then the problem and the challenge is the engineer transition, how the engineers start writing the code, which tools to use, everything of that. And one of the most challenges we face is the time implementation, which means, oh, I can fix that for 5 minutes, but if I need to write automation, I need to spend time talking about Python, what is Python, how to use it, how to use the automation, how to connect all the stuffs, you know? But you need to implement a framework to do that for you. So what is the framework? It's something like shared libraries. So if I write a library about authentication on different kind of boxes like Linux, ESX, and other switches, you don't need to do that over and over again. It's already there. So your engineers just log in without caring how it's working. More implementation of framework, more easy for your engineers. So what tools you can use? Whatever suits for you. Actually, in the early of 2000, there was like 1 or 2 tools, and you don't have so much choice. Right now, we have the opposite problem. Top 10 tools for configuration management. And you have top 10 tools, and you need to research them. What those tools are doing, what their purposes. So the 4 basic things you can implement are monitoring, which is watching about your problems, automation, which is doing that for you. Then it's the chat, or this is like, it's very good to have it, but if you have a chat, the automation can send you messages and just inform you. So you make the difference between reading your email and reading your chat, right? And then it's the ticket system. Why we need to have a ticket system in the automation? Because you want to have report. You want to know how much issues automation fix and what is the case to have a traction of the problem. So automation can raise your ticket, owns it, pull it out from your queue and work on it. Close it and that's it. Open, close. But you have report. After a month, you can check how much automation spends you. So let's talk about cost saving, how you can calculate that for you. The formula is pretty simple. You have your engineer cost, and you have time to resolve the issue. So if you multiply that, you're going to have the human hours spent over the issue. So we have a low disk space, and thus low disk space costs us that amount of money. And then you get the total cost of the resolving an issue. You can find that when you have all your incidents and all your human hours spent on those incidents. Then you're going to see how much from your budget is going out, right? And now the questions to you is, how many incidents do you have per month, per quarter, per year? And do you want to do something about it? SLA and SLO, for those who are not aware what is that, when you sign a contract with a customer, you agree on something. Let's say, I say that high priority tickets, let's say we have P1, P2, P3, the high priority tickets P2, I need to solve for 2 hours, 4 hours, 8 hours, and you sign off for that. And when you sign off, that means if you don't do it for 4 hours, for example, that's a cost for you because you didn't agree, you fulfill your documentation, legal documentation. So when the problems arise and the tickets is raised, the clock starts ticking. You have 4 hours to fix that issue. And now the question is, when the NOC teams hit the alarm, when the NOC teams decide when they fix the issue or not, if it's 5 minutes or 30 minutes, then they call the engineer. They cannot find the engineer. They call his manager. His manager finds another engineer. And at some point, from 4 hours, you have 30 minutes to fix it. And you breach the SLA. And now the question is, who do you think is faster? The engineers or the computers? Who can do it faster? Do you think you can do it faster from a computer? I'm talking about known issues, right? And then the biggest question in most of the teams are how to decide what to automate. It's very simple to say automate this, automate that, automate everything, but that's real story is you have different kind of issues and they can be very easy to automate, but they are very rare. So you need to think about this diagram and see that those are like small sliders. You go easy or you go difficult. And then you go rare or you go frequent. If you want to start with automation and consider auto-remediation, the advice is to start from something easy for you, just to get used to it. No matter if it's so frequent or rare. The idea is to start from somewhere. You need to start. And if you jump right away on like doing the huge codes and complicated solutions, it's not going to be so pleasant for you. So start from small and go over and over again. And at some point, you're going to have benefit of that. So you're going to say you cannot automate anything. And I can say, really? Do I? Can I automate anything? Everything? So the question is, when you start automating, it starts growing rapidly for you. What that means is your engineers are not burned out. They're happy. Happy engineer is doing more work. So he doesn't spend time fixing low disk space issues. He offloads that to the computer. And now he has more time. And more time means he can root cause analyze the more complex problems. That means if the problem arrives, he needs to find out what is the problem, actual problem, what is the causing it. And when you find the root cause, you attack that root cause, you fix it, and the real grail is you never heard of it anymore. But you don't have time because you're doing over and over, same thing every day. You're fixing wall disk spaces, some core dumps. You're doing it very regularly, and that's burning your engineers. They don't want to do the automation because they're not happy, they don't have time. And if you're scaling rapidly, the problems will never end. You will not receive like real world and expectations are completely different. You have new versions of the software, you have new hardware, you have new firmwares, so the problems will come over and over again. But because your engineers are not burnout, they continually fixing the root causes, and only the new things are there. And I heard a quote, it says, known evil is a good evil. So we know about that problem. So it's fine, because we know about it. But if something is new, that's a problem. So last things to remember is, and the questions to you is, do you want someone to call you at 1 a.m. and call you over and over again and wake up your dog and your wife? And remember, it's not a job. That's a passion. Thank you.
I think we have about 5 minutes for questions. Any questions?
So in your review process, do other system administrator review the code, or are developers involved in that as well?
They're involved both. And actually, we are E-Series, and the E-Series guy is in between the system administrator and the developer. So I can say that 90% of the cases, there are more system administrators. So it's like people like me, which are doing the code review. Okay.
Okay, thanks, Valentin.
Thank you.